The word tornado and the words Washington D.C. have never been comfortable neighbours. For most of living memory, the idea of rotating storms reaching the capital felt more like something from a movie than anything the real atmosphere would actually produce. And yet, on a morning that opened as one of the most welcoming spring days the city had seen in years, the kind of alert that does not belong in that sentence arrived anyway, and many people may still be wondering how it was possible. Stay with me, because in the next few minutes we're going to cover something important. We're going to talk about the specific geographic story behind why DC has historically been shielded from the worst severe weather and what was different about this particular storm. We're going to walk through the historical record and see how genuinely rare this kind of threat has been for the capital region. We're going to spend time inside that day itself, hour by hour, so you can feel what it was like to watch a single date move through what felt like 3 completely different seasons. And we're going to ask the question scientists are actively wrestling with right now, whether March 16th was a one-time outlier or one of several recent signals that something larger is shifting over the mid-Atlantic. Here is what made that day genuinely unlike what this region usually sees in early spring. The system responsible for it did not originate near Washington. It began as a powerful storm system several states to the west and north, as a powerful winter storm that buried portions of the Midwest under historic snowfall. Communities across the Great Lakes region experienced the kind of event that disrupted daily life and left a clear mark on local memory. But it did not stay that way. As it tracked eastward, it encountered something it had not brought with it. The warm, moist air that had settled over the mid-Atlantic during what was turning into an unusually advanced spring day. That encounter changed the storm's character in ways that most people outdoors near the capital that morning had no reason to expect what was coming. By the time the atmosphere had finished rearranging itself, tornado watches had been issued for the Washington area, confirmed rotating storms were tracking through nearby Maryland counties, and the beautiful spring morning had become something else entirely. Meteorologists described the situation as extremely uncommon for the nation's capital. That kind of language, from people whose professional lives are built around measured assessment, is worth paying attention to. If you found your way here from our earlier coverage of the Midwest blizzard that launched this entire storm system, welcome back. And if you're brand new here, and you want weather storytelling that goes deeper than the evening news, that connects real events to history, to geography, and to the places we actually care about, hit that like button right now and subscribe. Drop a comment below and tell me where you're watching from. Did this storm pass through your part of the country? Are you in the mid-Atlantic? Somewhere in the Midwest that knows this system by a different name? I read every comment in this community and everyone matters. Your perspective genuinely adds to these conversations. Now, back to Washington D.C. on that March morning? Because to understand why March 16th matters the way it does, you first need to understand something about this city that most people, including people who have lived there for decades, have never been told. You need to understand the geography secret, the quiet atmospheric story behind why DC has historically stayed safe, and why what happened that March day required something genuinely unusual to make it possible. Because the geography that usually helps protect this city was still doing its job, but this system had enough energy to partially push through. There is a story about Washington D.C. that nobody ever sat you down and explained, and once you understand it, the events of March 16th become even more remarkable. The reason the capital has historically stayed relatively protected from the worst tornado threats is not coincidence. It is not symbolic good fortune. It is a specific layered set of geographic and atmospheric conditions that have functioned like a quiet shield for generations. And like most shields, it works reliably, until it meets something powerful enough to seriously test it. Start with what sits to the west of the capital. The Appalachian Mountain Range runs along a long northeastern angle, separating the densely populated eastern seaboard from the interior of the country. These are not dramatic, towering peaks. They are ancient mountains, rounded and worn down by time in a way that makes them seem almost gentle on a map. But their effect on the atmosphere is anything but gentle. When powerful storm systems push eastward across the country, from the Central Plains or the Great Lakes region, the Appalachians force those systems to climb. In doing so, storms lose a significant portion of their low-level rotational structure, the very characteristic that makes them capable of producing tornadoes. By the time a system crosses those mountains and descends toward the coastal regions to the east, it has typically shed some of its most dangerous organizational energy. Season after season, storm system after storm system, The Appalachians have consistently weakened storm systems before they reach communities to the east. Then consider the water. The Chesapeake Bay, that long winding estuary sitting just to the east of the capital, creates its own set of atmospheric influences. The bay moderates temperature in ways that matter throughout the year. It introduces moisture into the air in patterns that interact with incoming weather systems in complex and often protective ways. The specific orientation of the bay, running roughly north to south along the coast, means that the moisture it contributes to the lower atmosphere frequently works at cross purposes with the dynamics that incoming severe storm systems need to maintain their most dangerous characteristics. This is atmospheric friction in one of its subtlest forms, not a hard wall, not a guaranteed defense, but a persistent ongoing interference that consistently tilts the probabilities in favor of the region beneath it. And then there is the transitional climate position of the city itself. Washington D.C. sits in a zone where the climate characteristics of the southeast and the northeast overlap without either fully defining the region. This in-between quality has historically been a form of protection in its own right. Storms that develop their most dangerous characteristics over the warm, flat, humid terrain of the deep south often encounter the mid-Atlantic as a place of interference. Temperatures that are not quite warm enough to sustain the worst dynamics, moisture profiles that are not quite as energized, terrain that introduces the complications described above. Systems from the north arrive typically too cold and too dry to maintain the rotating characteristics that produce serious tornado threats. Washington, D.C., sitting in the middle, has historically avoided the worst of these threats, exposed enough to get real weather, protected enough to avoid the absolute worst of it. Your grandparents may not have described it in those terms when they chose where to live, where to raise families, or where to put down roots. But that quiet sense of atmospheric stability, the feeling that the capital sits on somewhat safer ground than the storm-prone belt that runs through the heart of the country, has been embedded in how generations of Americans think about the region. People move to the D.C. suburbs not only for jobs and schools and proximity to the institutions of national life. They moved there, consciously or not, because the Mid-Atlantic carried the unspoken reputation of a place where the earth was not going to surprise you in the worst possible ways. That feeling was not built on nothing. The historical record genuinely supports it. The combination of those mountains, that bay, and that transitional climate position has provided a buffer that other major American cities like Memphis and Birmingham and Oklahoma City, simply do not have available to them. But here is the part worth sitting with carefully. A buffer is not a wall. A region that is historically sheltered is not a region that is permanently immune. The protection is real, but its effectiveness depends entirely on the nature of what is coming through. Most storms encounter those protections and yield to them, arriving at the DC metro area as loud but manageable weather events. A smaller number of systems arrive with enough energy, the right internal structure, and encounter just the right surface conditions on the receiving end that the geographic friction reduces but cannot fully neutralize the threat. March 16th was one of those less common setups that pushed past the region's usual protections. The critical ingredient that allowed the usual protections to be partially overcome was sitting right there on the surface of the region that morning. All that warm, moist air, the air that gave everyone a beautiful spring day, was simultaneously a direct contributor to the atmospheric instability the incoming system could exploit. The geography did its job. The Appalachians still disrupted the system. The bay still introduced interference. But the surface conditions beneath that arriving system were energized enough that what remained after the geographic weakening was still capable of producing a genuine, documented, officially confirmed severe weather threat over the nation's capital. That distinction, the geography working but meeting more than it was typically asked to manage, is what separates March 16th from the dozens of other systems that have approached the region over the decades and quietly yielded. Understanding that distinction is also what leads us directly to the next question worth asking. Just how rare was this kind of event, historically speaking? Because the answer to that question makes March 16th even more significant than the day itself might suggest. And when it comes to Washington, D.C. and the specific kind of threat that arrived on March 16th, the historical record reveals something that most people have never stopped to examine closely enough. The D.C. region has not been untouched by severe weather across its history. There have been significant damaging thunderstorm events that left neighborhoods without power for extended periods. There have been derecho systems, those long linear walls of destructive straight-line wind damage that travel across hundreds of miles in a single night, leaving trails of downed trees and structural damage from one end of a state to the other. The region has experienced serious flooding tied to slow-moving systems and the remnants of tropical storms that weakened over land before arriving. But tornado-specific threats, the kind involving confirmed storm rotation, the kind that prompted watches for the immediate DC metro area and warnings for its surrounding counties, those have occupied a genuinely different and notably shorter section of the historical record. When you start examining the actual timeline, what you find is not complete silence. It is a timeline with conspicuously long gaps between relevant events, long stretches of time where the capital existed in the kind of atmospheric quiet that most of the country, particularly the South and the Central Plains, simply cannot claim. Think about the decades that shaped the memories of many people watching this right now. The country moved through enormous transformation during those years, in its politics, its social fabric, its economy, and its identity. While Washington D.C. experiences fewer tornadoes than the Midwest, it is not completely immune, having recorded damaging storms in the past. The severe weather stories that commanded national attention during those generations came from somewhere else, from the communities in Alabama and Mississippi, where tornado season is an annual reality, from the Oklahoma towns where generations have built an instinctive, culturally embedded relationship with the spring sky, from the parts of Texas where a darkening western horizon in April carries a specific and deeply understood weight. Those stories did not come from the nation's capital, and over time, their absence from Washington created its own kind of certainty. People who grew up in the DC region during those decades developed a very specific relationship with severe weather, a relationship shaped not by alarm but by the consistent absence of it. They knew what DC summer thunderstorms looked like: dramatic, loud, occasionally powerful, but ultimately manageable in their personal experience. They knew the particular personality of a coastal nor'easter coming up the eastern seaboard in winter, bringing heavy snow and wind but following a familiar, predictable seasonal script. They built a mental model of DC weather that was fully grounded in everything they had personally lived through, and that mental model, reinforced across thousands of individual experiences and seasons and years, settled into something quiet and confident. Serious tornado threats almost never reach here. That mental model was not wrong in any simple sense. It was an accurate reflection of the historical pattern. The problem with mental models built on long periods of a particular kind of experience is that they update slowly. The confidence they carry feels completely earned, because in large measure it is earned. But earned confidence built on historical frequency is not the same as permanent safety built on structural guarantee. The events in the capital region that genuinely stand out in the severe weather historical record, the moments that produce something beyond the familiar summer storm narrative, tend to be separated from one another by significant spans of time. A real event would make local news. People would reference it through a season, perhaps two. And then the long quiet would return, and the region would go back to its usual sense of relative safety, and the default assumption would re-establish itself comfortably. This is not a tornado city. Compare that to the experience of communities in the Tennessee Valley or the Carolina Piedmont. In those places, awareness of spring severe weather is not a periodic conversation. It is a cultural inheritance. The knowledge of where to shelter, what to watch for, how to read a changing afternoon sky is passed from one generation to the next the way any vital community knowledge gets passed. The seasonal shift from winter to spring carries a specific respected weight. Not feared in a way that interferes with daily life, but genuinely and consistently taken seriously in a way that years of experience have earned. That kind of culturally embedded readiness was not present in Washington, D.C. on March 16th. It could not have been, given what the historical record had and had not provided. The city had simply not been given enough repeated first-hand experience with genuine tornado-level threats to develop the same kind of instinctive community-wide preparedness. Those long gaps in the historical timeline were not just gaps in weather events. They were gaps in the formation of collective awareness, in the lived experiential knowledge that turns a received alert into a meaningful behavioral response. What the historical record ultimately shows when you place March 16th inside it carefully is that this was not merely a statistically uncommon event. It was an event that broke through a very long period of relative quiet in a way that the people living through it had very little personal preparation to fully process. Because the mechanics of how this particular system made the journey from Midwest blizzard to mid-Atlantic tornado threat are every bit as fascinating as the history surrounding it. Most people, when they hear that a blizzard and a tornado threat came from the same storm system in the same week, react with the same quiet disbelief. It seems like an error. Like two separate stories got merged by accident. Two different kinds of weather, two different parts of the country, two different seasons in your mental calendar. The idea that one could flow directly into the other, that the same organized atmospheric process responsible for burying communities in snow could, days later, send rotating storm cells toward the nation's capital, challenges a very natural and deeply held way of categorizing what the sky does. But that challenge is exactly where the story becomes genuinely interesting. Because what happened between the Midwest snowfall and the DC tornado threat is a story about transformation, about how the same atmospheric energy changes its expression entirely as it moves through different environments, different terrain, and different combinations of air. And the best way to understand it is not through technical language. It is through a picture most people already know well. Think about a river that begins high in the mountains, where it starts, at elevation, in cold air, among narrow rocky channels. It moves slowly and carefully. The water is cold. It winds between boulders in a way that feels almost orderly. There is nothing about that mountain stream in that moment that signals any particular power. Up close, that kind of stream looks calm and manageable. It is organized. It is contained. It knows the boundaries of the channel it is moving through. Now follow that same water as it travels downhill. As it drops in elevation, it picks up speed. Other tributaries join it, adding volume without adding anything fundamentally new. The channel widens. The terrain changes from steep and rocky to open and flat. The same water that trickled quietly between rocks at the top of the mountain is now moving with enough force to reshape the landscape around it. Nothing new was added to the system. The energy was present from the beginning. What changed was the environment the water moved through, and the terrain that shaped what that energy was able to do. The storm system that became both a Midwest blizzard and a mid-Atlantic tornado threat worked on exactly this principle. In the northern part of its track, over the Great Lakes across Michigan and Wisconsin and the communities that got buried, the atmosphere above was structured around cold air in a way that channeled the system's energy into the signature of a major winter event. Heavy, organized snowfall over flat terrain already primed to accumulate it. That was the storm's identity in that environment. That was what it was doing with the energy it carried. But the storm did not stop there. It continued moving eastward and southward, and as it did, it encountered a surface environment entirely unlike what it had been travelling through. The mid-Atlantic region, on that particular March day, had warm and moist air sitting at low levels in the atmosphere. Not just slightly mild for the season, genuinely warm, unusually so for that point in March. The same warmth responsible for the beautiful morning everyone in Washington experienced. That surface air was energetic, unstable, and ready to respond if the right atmospheric push arrived from above. The cold system moving in from the west provided exactly that push. When cold, fast-moving air at higher levels of the atmosphere slides rapidly over warm, unstable air near the surface. The resulting vertical motion can be powerful and organized. The warm surface air surges upward. The cold air aloft moves quickly enough that it cannot simply mix gradually with what is below. Instead, the interaction produces strong updrafts, intense and localized pressure differences, and the rotational dynamics that generate severe thunderstorms and, given the right conditions, the rotating cells that carry tornado potential. This is the transformation. Not a separate storm, not a different weather event. The same organized system, finding a new and more violent expression because the ingredients it encountered changed what it could do. Washington, D.C. was positioned on that specific day at the receiving end of exactly this transformation. The warm surface air over the region was unusually developed for mid-March. The approaching system from the west was fast, well-organized, and carrying sufficient energy that even after the Appalachian interference described earlier, it arrived with enough internal structure to interact powerfully with the surface conditions it found. The geography reduced the threat, it did not eliminate it, and the result was a severe weather situation that was genuinely unexpected for this region, not because warnings were missing, but because most residents had never experienced this type of threat before, of what residents and even many forecasters typically anticipated for that region. What is equally important to understand is that this kind of transformation is not unique to this one storm. It is a recurring atmospheric process that happens with some regularity during the transition from winter to spring, when the seasonal contest between cold air from the north and warm air building from the south is at its most intense and unresolved. What made March 16th different from the many other springtime systems that have moved through the mid-Atlantic was the degree and combination of the ingredients, the unusual depth of the surface warmth, the speed and organisation of the arriving system, and the specific geographic outcome of where the most severe dynamics developed. Most of the time, when a winter storm transforms as it moves eastward, the rotating storm threat concentrates in areas that carry a deep, generational familiarity with it. The Southeast, the Carolinas, the Appalachian foothills communities where spring severe weather is a known seasonal reality. Those are communities where people check the forecast before committing to outdoor plans in late winter, where the spring skies read with attention and respect that accumulated experience has justified. Washington, D.C. is not one of those communities, and that gap between what the atmosphere proved itself capable of doing in the capital region and what decades of relatively calm experience had led residents to expect is where the real meaning of this event lives. Because the storm simply kept moving. It had built up enough energy across its long track to still be dangerous when it arrived in the east, transformed itself along the way, and delivered that transformed energy to a city that was still, in many ways, operating inside a different weather story. One that had been accurate for a very long time, but that, on March 16th, briefly and genuinely stopped being the whole story. There are days you remember not because of one defining moment, but because of how completely different the world looked at the end than it did at the beginning. March 16th in Washington, D.C. was that kind of day, not because of a single catastrophic event, but because the atmospheric distance travelled between sunrise and midnight was so far removed from what the morning had promised that it became genuinely difficult to hold both halves of the day in your mind as the same calendar date. The morning was beautiful in an honest, uncomplicated sense. The air was warm in a way that felt earned and settled. Not the uncertain, tentative warmth of early March when the temperature climbs slightly, but the winter feels like it is still testing whether it has truly let go. This warmth felt decisive. People made real decisions based on it, left heavier coats at home, chose outdoor seating when they had the option, walked instead of drove, made plans that assumed the evening would continue in the same register as the morning. Around the monuments that morning, visitors were out in numbers, drawn in by the unusually warm weather. The early spring visitors to the National Mall represent a specific kind of energy, a mixture of people fulfilling long-held plans and people who simply responded to the morning by stepping outside. On March 16th, the mall was busy with people who had no reason to expect what was coming later that day. The sky was clear, the air was cooperative, everything felt as it should. What those people could not see was the atmospheric setup building above them that morning. The warm surface air, that same warmth that made the morning so pleasant, so inviting, so certain feeling, was simultaneously creating the surface energy profile that the approaching system from the west would be able to exploit. The depth and unusual warmth of the low-level air on that morning was notable even by the standards of an advanced spring day. It was the kind of atmospheric condition that draws measured attention from the people whose professional responsibility is to watch for it. As the morning moved toward midday, the changes in the sky were subtle enough to miss if you were not specifically watching for them. The light shifted in a way that might have registered as ordinary afternoon cloud development to most people. The air began to shift in the way it typically does ahead of an organised incoming storm system, building in gradual accumulation rather than arriving as a single obvious signal. Each individual change looked manageable on its own. The picture only becomes clear when you step back and observe how far the sky has travelled across 2 or 3 hours. By early afternoon, the western horizon was showing the kind of tall, active clouds that signal a strong storm system approaching the cloud structure. Building in that direction carried a particular vertical quality, the kind of towering, active cloud development associated with genuinely energized convection rather than the flat, horizontal layers of ordinary overcast. People familiar with severe weather in other parts of the country would have recognized the signature. For most residents of Washington, D.C. that afternoon, the clouds likely appeared unusual but not alarming. Tornado watches were issued while the afternoon was still in full motion, while people were still completing workdays, making plans, considering evening options. That timing is worth dwelling on. Watches arriving during the active, busy middle of a weekday afternoon land in a fundamentally different cognitive environment than warnings arriving at midnight when the world has already quieted and prepared for rest. In the afternoon, the information competes with everything a fully occupied day demands, and when the category of the alert Tornado Watch for Washington D.C., carries no strong personal reference point for most recipients. The translation from received information to genuine behavioral change happens slowly and incompletely. The afternoon moved toward evening. The wind shifted. That physical change in air direction, distinctive, sudden, felt on the skin before it is consciously registered, is one of the clearest atmospheric signals of an approaching organized severe weather system. In communities where this kind of threat is part of the seasonal vocabulary, that shift is recognized immediately and responded to without deliberation. For most people in DC, the sudden wind shift likely felt unusual, but did not trigger a clear response. Confirmed rotating storms were tracked through nearby Maryland counties. Warnings were issued. Those in the outlying areas were strongly advised to take shelter. The evening, which had started as the most welcoming afternoon of the young spring season, had travelled to a place that was genuinely serious, not in the sense of an imminent catastrophe to the city itself, but in the sense that the atmosphere over the region was producing the specific conditions that warrant the response protocols they were designed to prompt. And then the temperature began to fall, not in the gradual, comfortable way temperatures ease down after a pleasant summer evening. The cold front arrived quickly and sharply, and temperatures began falling fast. Within just a few hours of tornado warnings being issued in the suburbs, the temperature in the city dropped sharply toward near freezing. People who had made their morning clothing decisions based on one of the warmest days of the year were now confronting overnight conditions that belonged to a completely different month. 3 seasons in 12 hours, spring in the morning air, a summer-style severe weather pattern across the afternoon and evening, a near-winter overnight that reset the city's atmospheric calendar entirely. What that compression quietly reveals is how quickly the world we assume we are living in can shift around us, which raises a question worth asking with genuine curiosity. What would those structures actually face if the worst of what moved nearby that day had arrived directly? There is a question that sits at the quiet edge of what happened on March 16th, one most people approach carefully, if they form it at all, because asking it out loud feels uncomfortably close to something we would rather not examine. But it deserves a calm, grounded, genuinely curious examination, because the answer is more nuanced than the disaster narrative that tends to fill the space when no honest answer is offered. And the honest answer is, in some important ways, more interesting than the scenario most people quietly imagine. The Washington Monument is the structure most people's minds reach for first. It is the most immediately visible symbol of the mall skyline, that narrow, tapered obelisk rising above the surrounding landscape with a geometric simplicity that makes it impossible to ignore. The monument was completed in the 19th century in 2 distinct phases, separated by decades of funding delay and management changes. If you examine the stone surface carefully, the slight colour variation still visible today marks exactly where the first construction phase ended and the second resumed. A historical seam in plain sight that most visitors walk past without noticing. The obelisk form is not merely a stylistic choice. A tapered pyramidal profile is one of the more structurally efficient geometries a tall, narrow structure can take when it comes to managing lateral forces, including wind. The walls are genuine load-bearing stone, thick at the base and gradually tapering as they rise. For most wind events, including significant non-tornado thunderstorm winds, the monument's geometry helps redirect force around the structure rather than absorbing it squarely. The historical record confirms it has survived major storm events without catastrophic structural failure across well over a century of mid-Atlantic weather. For tornado-force winds at their most intense, the honest conversation changes, not because the monument's construction is inadequate, but because the force category is genuinely different from what the structure was originally designed against. The realistic concern is not the obelisk toppling. It is the indirect environment a serious tornado would create in the surrounding urban landscape. The debris in motion, the pressure fluctuations, the thousands of trees and nearby structures that could become debris, which is the real concern in any tornado scenario, even for stone that could withstand the wind loading itself. In a tornado near the mall, the biggest concern would likely be debris from surrounding trees and structures, not the monument itself. The Lincoln Memorial offers a different conversation entirely. Its wide, low, columned profile represents a fundamentally different approach to permanence than the monument's vertical form. Wide and low structures manage wind loading differently than tall, narrow ones. The horizontal mass distributes force in ways that favour the structure's stability under lateral pressure. The memorial's enormous weight, the broad horizontal footprint, the open colonnade that allows air to pass through rather than striking a solid wall, these characteristics work together in the structure's favour. The Lincoln Memorial was built by architects and engineers thinking in generational terms, designing explicitly for durability that would outlast the conditions of any single era. The Capitol dome sits in a particularly fascinating position in this conversation, and it contains a detail most people do not know. The current dome, the one visible in every photograph taken from the length of the mall, replaced an earlier, much smaller structure during the Civil War era. That replacement was not only an engineering decision, it was a symbol of national continuity, chosen to continue even during one of the country's most difficult periods. The decision to continue construction during those years carried symbolic weight that the engineering served. The dome itself is cast iron, a material that consistently surprises people who assume they are looking at stone from the outside. Cast iron performs differently under stress than modern structural steel, with distinct characteristics around how it responds to sudden, intense lateral loading that a direct tornado impact would represent. It is worth noting here, as an honest part of this conversation, that the observations about these structures reflect their historical construction and general architectural characteristics, not a formal engineering assessment of any specific scenario. But in practical terms, what actually happened on March 16th was consistent with the city's historic experience: serious atmospheric conditions in proximity to the Capitol, genuine concern warranting official alerts and responses, but no direct impact on the landmark structures themselves. The confirmed rotating storms were tracked through nearby counties, including Calvert County, Maryland. The immediate D.C. area was under a watch, while the most active storm cells were confirmed in surrounding counties. What is worth carrying away from this part is not a damage scenario. It is an appreciation for what it means that people have been building structures in this city for the better part of 3 centuries with the explicit intention of permanence. The architects and engineers behind the Washington Monument, the Lincoln Memorial, the Capitol, and the Smithsonian buildings were designing for endurance: physical, symbolic, and historical. They built things that have already outlasted every weather event the region has encountered in their combined lifetimes. The evidence of what they created is visible in the fact that those structures still stand exactly as they were meant to. But the people who live and visit and work in the shadow of those structures carry their own kind of vulnerability that stone and cast iron do not share. And the awareness of that human vulnerability, the gap between how many people were moving through that environment on March 16th and how many of them had a clear and grounded understanding of what was building overhead, is its own important story, one that points directly to a number that deserves its own careful attention. Here is something worth sitting with for a moment. On March 16th, the number of people under tornado watches across the East Coast stretched into the tens of millions. Tens of millions of people across cities, suburbs, and small towns running up the Atlantic coastal corridor, officially living inside a formally designated severe weather watch area. And for a substantial portion of them, the day passed with a level of awareness that did not reflect the seriousness of the atmospheric situation they were inside of. It is one of the most genuinely important observations that comes out of this event, and it deserves careful, honest examination, rather than being used as an indictment of any individual or community. We exist in an era of information availability that would have seemed almost impossible to the generations who navigated the worst severe weather events of the mid-20th century without it. Emergency alerts can reach virtually every smartphone within a designated geographic area in a matter of seconds. Radar mapping tools give ordinary people access to the same basic visual information that professional meteorologists work with, and yet, on a day when a historically unusual severe weather event was unfolding across one of the most densely populated corridors in the country, a large portion of the affected population was not operating with the level of awareness and readiness that the situation warranted. The alerts came, the watches were issued and distributed, the information existed in every pocket and on every desk. But information existing and information genuinely landing, connecting with a person's real-time understanding and prompting an actual change in behavior, are 2 fundamentally different things. The gap between them is where the most important part of this story sits. Consider what the tourists on the National Mall were likely focused on that afternoon. Many of them had travelled significant distances for this visit. They were standing in the presence of places they had seen in photographs for their entire lives and had finally arrived to see in person. That emotional and experiential context is not a small variable. When someone is visiting the Lincoln Memorial for the first time, especially with family, their full attention is on that experience, not on a weather alert. An alert arriving on a phone competes with that context. For many people at that moment, the competition is genuinely uneven, and the alert does not win. Think about the evening commuters working their way through metro systems, parking structures, and suburban roads as the afternoon shifted toward evening. They were engaged in the familiar end-off-workday choreography, the routine logistics that occupy attention in an almost automatic way. A severe weather alert landing into that routine, in a category, Tornado Watch for Washington D.C., that carries no strong personal reference point for someone who has lived in the area for decades without experiencing a serious tornado threat, may register as surprising without registering as urgent. The cognitive distance between receiving an alert and changing behavior in response to it depends heavily on past experience and the personal reference points that experience provides. And the key point is this: most DC residents did not have those reference points. The awareness gap that emerged on March 16th was not primarily a failure of technology or a failure of the warning system. It was a gap of lived experience, a gap of the specific cultural familiarity that only develops over generations of exposure to a particular kind of risk. In the communities that have grown up living with genuine annual tornado risk, in central Tennessee, in North Texas, in the suburbs of Oklahoma City, weather preparedness is not a response to crisis. It is a cultural inheritance. Families discuss shelter plans in quiet, ordinary moments during early spring. Schools treat severe weather drills with the same institutional seriousness as fire evacuation procedures. The local evening weather segment carries a specific authority and engaged viewership that comes from generations of demonstrated relevance. There is a living, shared vocabulary around weather risk that makes the space between receiving an alert and acting on it very short, because the community has spent decades building the connective tissue between the two. Washington, D.C. has never been required to build that vocabulary, and you cannot build a generation of atmospheric experience and community readiness in a single afternoon. What this points toward is a genuinely important question about how communities develop, or fail to develop, the awareness infrastructure that shifting patterns of risk actually require. The traditional tools of emergency communication do their job of reaching people. They are less equipped to provide the context that transforms received information into meaningful, proportionate action. That context is built through time, through repeated engagement, through the kind of personal and shared experience that eventually moves a topic from abstract to genuinely felt. The most powerful form of that context building is not institutional. It is not a new alert format or a government awareness campaign, though those have real value. It is the conversation that happens because someone understood something clearly enough to share it with someone they care about. The person who watches a video like this one and mentions to a family member in suburban Maryland that DC's geographic protections are real but not unlimited. The grandparent who calls a child living near the Capitol after learning something they had not known before. The neighbor who checks in on the person next door not because an official notification told them to, but because they understood, specifically, personally, concretely, what the atmosphere had been doing. That kind of awareness is what the gap on March 16th actually calls for, and building it starts not with fear, but with understanding the larger pattern that this day belongs to. Every so often, a single event becomes a reference point, not because it was the most severe version of something that had happened many times before, but because it crystallized a shift that had been accumulating quietly for years and made it genuinely impossible to overlook. March 16th in Washington, D.C. could become one of those reference points for the Mid-Atlantic region, not for the severity of its immediate impact alone, but for what it represents when you place it honestly inside a larger and growing body of documented evidence. Scientists who study the geographic distribution of severe weather across the United States have been tracking something for years that has not received the sustained mainstream attention its implications deserve. The traditional geography of tornado risk in this country, concentrated in the Central Plains and the Deep South, anchored in the familiar corridor that most Americans learned about in school and see represented on standard weather maps, is not as fixed as the historical record of the mid-20th century might suggest. Researchers examining storm occurrence data across recent decades have been documenting a pattern of gradual geographic expansion, with meaningful severe weather activity occurring with higher frequency in areas that the longer historical record had categorized as being at lower risk. The Mid-Atlantic and the Northeast are among the regions where this documented shift is most directly relevant. This is not a claim that the traditional tornado zones are disappearing or relocating wholesale to the East Coast. The Central Plains and the Deep South continue to experience the most consistent, most frequent and most intense tornado activity in the country. That foundational reality has not changed and shows no indication of doing so. What is changing, gradually, measurably, in ways that accumulating research supports with increasing clarity, is the outer boundary, the frequency of the edge cases. The events that were historically rare in specific geographic contexts are occurring often enough in new contexts that experienced researchers are paying deliberate, sustained, methodical attention to what the data is showing. The Mid-Atlantic Corridor specifically, the densely populated stretch of urban and suburban America that runs from Washington through Baltimore through Philadelphia toward the major metropolitan areas of the Northeast, is sitting in the zone where this documented shift is most immediately relevant. Each event in that region, looked at on its own, could seem like a rare but random occurrence. Looked at together, though, researchers say they may point to a broader pattern worth watching carefully. Not every researcher examining this data reaches identical conclusions, and intellectual honesty requires acknowledging that. The science of weather pattern attribution is careful, deliberate work, and presenting any single cause as fully settled would be inaccurate. What can be said with confidence is that the observation that something meaningful is shifting in the distribution of severe weather risk across the country, with the Mid-Atlantic region as one of the areas of growing concern, reflects what a genuine and expanding body of peer-reviewed research is finding, and it is not a fringe position. For the people watching this who have lived decades in the D.C. metro area, in Maryland, in Virginia, in the suburban communities surrounding the capital, this is not intended as an alarm, it is intended as an honest orientation. There is an important and deliberate difference between those two things. Alarm pushes people toward either panic or dismissal, neither of which serves anyone well. Orientation gives people something they can actually use, a clearer picture of where they are standing relative to a pattern that is still developing, and will continue to evolve. What this means practically is more modest and more achievable than any dramatic response would suggest. It means that the family in the DC suburbs who has never needed to think seriously about where they would shelter, if a tornado watch escalated to a warning, might benefit from having that quiet, practical conversation now, not in a state of alarm, not in response to an active emergency, but simply because the long historical certainty that this doesn't happen here has become slightly less reliable than it used to be. And a calm conversation on an ordinary afternoon about the safest interior room in a house costs nothing and carries real value. It means that the generation of Americans with deep roots in the capital region, who have walked those streets for decades, who feel genuine personal connection to the monuments and the neighborhoods and the institutions that define the city, carries a kind of community knowledge and historical grounding that becomes more valuable, not less, when familiar patterns begin to shift. The person who has seen enough of the world to help a neighbor navigate something new without catastrophizing it is exactly the kind of community anchor that these moments call for, and it means that the remarkable thing about March 16th is not that it became a disaster. It did not. The warnings functioned. The storms tracked through without delivering their worst potential outcome. What is remarkable is that it happened at all, that the specific combination of atmospheric ingredients assembled itself over the capital of the United States on a morning that had felt like the most ordinary and welcoming kind of spring day, and produced a situation that the city's residents had historically never been required to seriously prepare for. That quiet confidence, the one that said the worst does not come here, was not a weakness. It was a reasonable and historically supported response to the record. But historical patterns show what is common, but not what is guaranteed. And when a new data point arrives that breaks cleanly and documentably from the pattern, when a storm buries the Midwest and then sends confirmed rotating storm threats to the nation's capital in the same week, the responsible response is not to file it away as a curiosity. It is to ask honestly what it is telling us, and to listen carefully to the answer. What happened on March 16th was genuinely uncommon for this region, and the weather record supports that. The atmospheric dynamics behind it are specific and well documented, and the larger pattern it belongs to, the gradual but real shift in where severe weather is now willing to go, is something that informed, historically grounded, thoughtful people are exactly the right audience to understand, to hold, and to share with the people around them. If this video left you with something to carry forward, something to think about, something worth passing along to someone who lives in the capital region or along the eastern seaboard, then it has done exactly what it was built to do. This channel exists to go deeper than the headline, to connect what happened to why it happened, and to connect why it happened to what it means going forward. If you are not yet part of this community, now is the time to hit that subscribe button and join. Drop a comment below telling me where you're watching from and whether this storm system touched your corner of the country. I read every single one, and the next video continues this story, in a direction that I think is going to stay with you. I will see you there.